Morning all. In the last lecture, we have completed our second unit. Now we move forward with our new, that is third unit. Its name is highway materials. Okay, this is a very important unit as far as the if you are going to the be a site engineer, then it is very important unit for your information. So you should understand how the materials are used on the site, how to perform the tests on the various kinds of the material on the site. Okay, if there is there are mainly we are dealing with the soil aggregates, okay, and the bitumen. Okay. So these are the very main important parameters that we need to test in the laboratory or on the site. Okay, to perform or to carry out its characteristics, its strength points, then and then only we can judge or we can say if that material is whether useful on the site or whether it is not useful on the site. Okay, so this is a very important chapter as per as our highway engineering is concerned. So we need to understand all the materials, its properties, its strength points, its characteristics, and all that. Okay, regarding the all materials. So let's start. Syllabus that we are going to cover in this chapter is the properties of the subgrade and the pavement component materials. Okay, what are the pavements and what are the properties of that pavement subgrades that we are going to cover. The tests on the subgrade soil. On soil, we are performing the CBR test and the plate loss test. Okay, CBR strength test is generally used to find out the stability of the soil or the strength of the soil, and the plate load test we are performing for carry out the modulus of elasticity of the soil. Okay, that we are going to find out by these tests. How to perform this test on the soil? These tests are for the soil. Okay, they are performing the CBR and plate load test on the soil. How to perform that we will see at that time. The properties and the requirements of the load aggregates and the bituminous materials. Okay, then also we are need to study the properties of the road aggregates. Which properties we should understand? The strength of the aggregate, impact strength of the, that is toughness of the aggregate, hardness of the aggregate, okay, specific gravity of the aggregate, abrasion resistance of that aggregate, wear and tear resistance of that aggregate. Okay, all such properties of that aggregate we need to study and we need to understand in this chapter. Okay, and to carry out these properties or to study this property, we have to carry out a certain tests. To find out the strength, we need to go for the crushing test. To find out the toughness value, we need to go for the impact test. To find out the hardness, then we need to go for the Los Angeles test. Okay, likewise tests we have to perform on the aggregate. Then we need to understand the properties of that aggregate. Then we are going to see the tests or the various properties regarding the bituminous material, like the specific gravity of the bitumen, okay, the elasticity of the bitumen, softening point of the bitumen, okay, flash and fire points, okay. Such properties of the bitumen we will go into study. Then the bituminous mix designed by the Marshall method, application of the geosynthetics and the modified binders in the road construction. So this much is the syllabus that we are going to cover in our this third chapter. So first we will start with the what is meant by the pavement. So the pavement is the structure consisting of the superimposed layers of the processed material above the natural soil of subgrade, whose primary function is to distribute the applied wheel loads on the subgrade. Okay, what is the pavement? If we are riding our vehicle, then the wheels of the vehicle will give some stress, will give some load on the road. Okay. So distribute that wheel load, we are going to construct the pure. Okay. Because the load is evenly distributed on the subgrade. Subgrade means what? The layer of that soil over there. Whatever the layer of soil we are there, on that layer of soil, we need to distribute our wheel loads. Okay. And for that purpose, to distribute the wheel loads, we are going to construct the pyramids. That may be the flexible pyramid, that may be the rigid pyramid. If the flexible pyramid will be there are the certain different layers for the flexible pyramid. If there is a rigid pyramid, there are different layers for the rigid pyramids. Okay. The pyramid structure should be able to provide a surface of the acceptable riding quality, adequate skid resistance, favorable light reflection characteristics, and the low noise pollution. The ultimate aim is to ensure that the transmitted stress due to the wheel load are sufficiently reduced so that they will not exceed the bearing capacity of the subgrade. Okay. So what should be the qualities of the pyramid? That the pyramid should be good enough for the resisting the wear reactive. Okay. It should give the adequate skid resistance. Also, it should give the favorable for the light reflecting characteristics. Okay. It should give the very good comfortable condition or the very good comfort to the riders. Okay. That qualities of that pyramid should be. Why should we go for these characteristics of the pyramid? Because our ultimate aim is to ensure that the whatever the load it is there due to the wheel, that load should be properly transmitted to the subgrade soil. Okay, because if the load will be more than the bearing capacity of that soil, then the soil will get fair or our foundation will get. You might have learned into the geotechnical engineering. How does the bearing capacity of soil is affected due to the loss? Okay, how does calculate the bearing capacity of the soil? Okay, how it is very important to design. Okay. So ultimate aim of our designing the pyramid is that whatever the load it's coming from the pyramid to the subgrade soil, the load should be such that it should not increase above the bearing capacity of the soil. Okay. So this will be our aim whenever we are designing the pyramid. It should not get overloaded to the subgrade soil. There are two types of the pyramids are generally recognized as the service. This purpose named are flexible pyramid and rigid pyramid. Okay, to serve this purpose, there are two types of the pyramids are designed. One is the flexible pyramid, another is the rigid pyramid. In flexible pyramid, we are using the bitumen, and in the rigid pyramid, we are using the concrete roads. Okay, whenever there is a concrete road, we call it as rigid pyramid. If there is a bituminous road, then we call it as a flexible pyramid. Okay, what are the characteristics of this rigid and flexible that we have learned in the first chapter? How why we call it as a flexible pyramid? Why we call it as a rigid pyramid? Okay, that we have studied in the first chapter. We are not going there deep. So next is C. We have shown the picture of the pyramid. Okay, so these are the some requirements of the pyramids. An ideal pyramid should meet the following requirements. Sufficient thickness to distribute the wheel load stress to the safe value on the subgrade side. Okay, it should give the sufficient load stress distribution over the subgrade side. Okay. That should be the requirement of the pyramid. First and prior important. Structurally strong to withstand all types of the stresses imposed on it. whatever the stresses will be there on the pavement, that all the stresses that should be imposed with the by the pavements. Okay, the stresses may be due to the wheel load, stresses may be due to the temperature variations. Okay, any kind of the stresses will be. Okay. So that stresses should be beared by that pavement without any failure. Adequate coefficient of the friction to the pavement skidding of the vehicle. Okay, we should give the very good coefficient of friction so that the vehicle will not get skid. Okay. Smooth surface to provide the comfort to the road users even at the high speed. This is also very important. Whenever the any driver or any uh, road user is there that is driving on that road, that should he should feel very comfortable to drive on that road. So that pavement should give the comfort condition to the driver or to the road user. This is also very important. Whether he is driving at a 30 kmph, whether he is driving at 150 kmph, doesn't matter. At very high speed also, that road should use the at high speed means what? At is safe speed limit. Okay, whatever the speed limit that is designed at that road, at that speed limit also, it should use the comfort condition to the road user. Produce least noise from the moving vehicles. Okay, the pavement should not create too much noise. That should provide, that should be the characteristic of the pavement, that should use the less noise pollution. Dust proof surface so that the track safety is not impaired by the reducing the visibility. Okay, the pavement should not use the dust on the road. Okay. Due to the wear and tear, there may be the chances of the rigid pavement to form a dust. Okay, so we should be assured that by the abrasion or wear and tear of the pavement, it should not produce the dust because it will reduce the visibility of the travel. Okay, the visibility will be affected due to the dust. So we also have to see about the dust proof surface of the pavement. Impervious surface so that the subgrade soil is well protected and the long design life with the low maintenance cost. Okay, the surface should be the impervious as well as the surface should be given a slight slope so that whenever the water will be there, that will be removed out. Okay, that will be flow out to the channels. Okay, so that if there is not accumulation of the water, there will not be any chances of hazardous on the road. If there is the accumulation of the water, then ultimately by the loads, if the water will be there, that water will be enter into the subgrade and that also affect on the bearing capacity. Okay. So we should have to protect our surface from the by the impervious surface so that the subgrade soil is well protected and long design life with the low maintenance. If the pavement is very good with the condition, then we need not to go for the maintenance. If it is not good, then we have to go for the maintenance rigorously. So the types of pavements, the pavements can be classified based on the structure performance into two types. One is the flexible, another is the rigid. Okay, so these are the two types of the pavements. See here they have shown the typical diagram of the pavements. Please draw this diagram. Give the heading as types of pavements. One is the flexible pavement, second one is the rigid pavement. Flexible pavement, another is the rigid pavement.
Okay, my
We can increase the layers, also we can reduce the layers. Okay, depending on the traffic density on that road, we alter the layers. Okay, we directly see here in the flexible pavement, after the surface dressing course, we have directly put at the base course. In between that, we can add also binder course, then sub base course, then base course, then the sub layer. Okay, likewise we can go. It depends on the traffic conditions. We should get difference between the flexible pavement and rigid pavement. Okay, so see here in the diagram, they have shown the first layer of the flexible pavement is the surface course. Okay, the first layer on the top, or we should go with the bottom. Okay, we'll go reverse. We will start with the bottom because whenever we are constructing the road, we construct from the bottom. Okay, so at the first, there is the soil. Okay, so we need to compact the soil in such a way that that should be gives a very good bearing capacity. Okay, so the first important parameter is to compact that available natural soil, that also we call the natural subgrade or the subgrade. Okay, that we need to go for the compaction. Okay, the very good and firm compaction that should be done by the compactor on that side. Okay, then what we have to do, we have to form a sub base. Okay, then we need to form a subbase. For that, we need to add the boulders, aggregates of the large size, etc. And then we need to go for the compaction of that sub base by the compact. Okay. You might have seen when there is the construction of road. They firstly do the compaction of the site, then they will apply the aggregates of the large size that is called boulders, etc. They will apply, then we will go for the compaction. Then they will apply the base course. Okay, that might be the mixture of the aggregates and the bitumen. Okay, so they will apply the base course. They will go with the compaction of the base course, and finally at the last they will apply the surface course. Okay, in the base course and the sub base course, if there is a necessity, they might be used as the binder. Okay, they may use the binder in between the base course and the surface course if required. Okay. If not, they will not use. So these are the layers which are step by steps formed during the construction of the flexible pavement. Okay. And when there is a construction of the rigid pavement, that we need not to go further that much cases. Only we have to form only one layer that may be called as base, that may be called as sub base. Okay, only one layer we have to form there, and then after the compaction of soil, okay, after the compaction of the soil at the very good condition, then we need to apply one layer that may be a base, that may be sub base, and then we need to go for the formation of the concrete layer. Okay, there are nowadays there are direct machines with the certain specified length of the one lens. Okay, they will directly place the one lane at a time with the machine. So they will form the rigid pavement. Only the thing is to achieve the quality in the construction, so that we need to achieve the proper grade of the concrete. Okay, to achieve the proper quality of the road, we need to achieve the proper grades for the concrete. See here, they have shown the figure. This is the flexible pavement, and at the right side there is the rigid pavement. So see, and please observe one thing. Always, please see here. What is this? You might have seen on the concrete road. There, after the certain length, they will cut the road. Okay, by the machine. They will cut horizontally as well as vertically, that is longitudinally as well as in the transfer direction. They will cut the road. Okay, but there there will not be any cut on the flexible. Okay, there will not be any cut on the flexible. Why this is provided on the concrete road only? Why it is not provided on the bituminous road? Can anyone tell? What is the reason behind to provide this longitudinal joint and transverse joint? Can anyone tell? Anyone knows? Why we provide on the concrete road? There are cuts you might have seen, transverse and longitudinal direction. Why they have provided? Why they are not there on the bituminous road? Bituminous road वरती नसतात, फक्त concrete वरती असतात. What is the reason behind that? So see, I will tell, please listen carefully, because the concrete is very susceptible for the temperature stresses. The reason behind this is the temperature stresses. Okay. What is this temperature stresses? How they have generated? They are generated. See, whenever there is a rise in temperature, okay, whenever there is a rise in temperature, it will tries to elongate. Okay, it will tries to elongate. And whenever there is the fall in temperature, it will tries to accumulate. Okay, whenever there is a raise in temperature, it tries to elongate. Whenever there is a fall in temperature, it tries to accumulate. Due to this, what will happen? There will is the chances of the production of stresses. Okay, how you? I will tell one example for that. You will easily understand that. See, you have studied in the strength of material. So, if suppose this is the a this end is constraint, okay, that is fixed, and I have placed one rod here. Okay, suppose I will hit this rod, or I will increase the temperature. I will increase the temperature. Due to the increase in the temperature, there will be the elongation in the rod. Okay, there is an increase in the length of the rod. We calculate as a delta L, as alpha TL. Okay, by the formula alpha TL. You might have learned. We calculate the change in length by the alpha TL. I think this is the formula. Okay. This change due to the change in temperature or the increase in the temperature, the length of the rod will get increases. Okay. So if there is a chances to the rod to increase, there will not be any stresses induced into the rod. Okay. If the rod is free to increase or elongate due to the temperature increase, there will not be any stresses on the rod. Now see here what I will do. If I will put another constraint on this end, this what I will fix this rod from the both the sides. Okay, I will fix this rod from the both the sides. Now what will happen if there is a rise in the temperature? The rod will tries to elongate. Okay, if there will be the rise in the temperature, the rod tries to elongate, but I have placed the fix the condition on the both sides. Okay, the rod will not get elongated. Okay. The rod tries to elongate, but the constraints doesn't allow him to elongate. Okay, so what will happen due to this? There will be the temperature stresses induced into the rod. Stress, when the stress is induced or when the stress is created, when something happens against your mind. Okay, when we call I am in the stress, when something is happened against your mind. Okay, here also when something's happen against the rod means what? Rod like or rod is likely to increase its length or elongate due to the temperature increase, but the restrained conditions are there, the ends are fixed are there, so that the rod cannot increase the length. Okay, he want to elongate, but restrained or the fixed condition doesn't allow him to elongate. Okay, due to this what will happen? The stresses will be induced into the rod. Likewise, the same application will be there here on the road also, because the road is rigid here. Okay, if we consider the flexible pavement, there the pavement is flexible. It can elongate or accumulate because it has some flexibility. That's why it is called as flexible pavement. But here it is rigid pavement, so that the whenever he tries to elongate, if he is not allowed to elongate, then what will happen? There will be the cracks on the pavement. Okay, so we need to give the horizontal, longitudinal, and the transverse joints to the roads for avoiding the cracks on it. Okay, so these are provided to avoid the cracks on the road due to the temperature stresses. Understood? So these are the joints, transverse and longitudinal, are provided on the rigid pavement to avoid the cracks due to the temperature stresses. Then we'll see the flexible pavement. Flexible pavement will transmit the wheel load stresses to the lower layer by the grain to grain transfer to the points of the contact in the granular structure. Okay, what is the transfer load transfer mechanism into the flexible pavement is grain to grain, because there are too much amounts of grains, that is aggregates are there, boulders are there. Okay, so grain to grain transfer of the load will be there in the flexible pavement. Okay. The wheel load acting on the pavement will be distributed to the wider area and the stress decrease with the depth. Okay, as we go into the wider transmission of the load, what will happen? The stress will get reduced, because we know, right here, because we know what is the stress. Stress is equal to whatever will be the load upon area. Okay, so if we go on increasing the area of the distribution of the load, what will happen? If the area is increasing, the stress will go on decreasing. Okay, so we need to distribute the stress on the wider area, so that what will happen? There will be the less stress generated on the soil. Okay, if the depth of the pavement it is more, it will give the wider area to distribute the load. Okay. If the wider area is there for distribution of the load, there will be the less production of the stress on the soil. Okay. Then the flexible pavement normally has the many layers. Hence, the design of the flexible pavement uses the concept of layered system, because there are multiple layers in the flexible pavement, so that we need to go with the design the flexible pavement in the layered system. Okay, in the rigid pavement there are single layer only, or else we will go with the two layers. But in the flexible pavements there are number of layers: surface layer, binder layer, then the sub base layer, subgrade layer. Okay, likewise layers are there in the flexible pavement, but in the rigid pavement there is only concrete layer at the top, that is surface layer, and the base layer. Okay. So we need to go for the use of the concept of layered system into the flexible pavement. So this is the typical diagram of the flexible pavement. Please draw this diagram also. This is a very important diagram. Give the heading as flexible pavement. Give the heading as a flexible pavement. And draw this diagram. This is important diagram. In the MPSC, they have directly give ask the diagram for the pavement. Okay. They have given the diagram for the pavement, and they have asked the question like whether this diagram is for the flexible pavement in the rigid for the rigid pavement, etc. Like this. Once they have asked this question, so you also should know the layers of the pavement. Please draw this diagram. They also have given the sizes of the layers. The sizes are depends on the traffic conditions over that layer, road. Okay, that may be vary. Okay, if there is a high traffic, then we need to go for the more size of the layer, the more thickness I can say of the layer. If the traffic is less, then I will go with the less thickness of the that respective layer. Okay, and I may reduce the layer depends on the traffic condition. Okay, we'll move forward if you have time. So see here, so these are the different layers that we are going to provide or we provide on the flexible payments. Okay, that these are the layers that are generally used into the flexible payments. So at the bottom there is a natural soil which is undisturbed. Okay, then we provide the compacted subgrade. Okay, means what with the if there is a soil layer, we will compact it with the compactors. Then we provide the subbase cores. Then also we will go with the compaction. Then we provide the base cores. Then provide the binder cores, and then we will go with the surface cores. Okay, so the, at the top of the surface core, we will provide the seal coat to avoid the entry of the waters. Also, for that purpose, we can also provide the layer at the base, top of the bind and base of the surface, that is stick tack coat, and also we can provide the prime coat. Okay, so what is these coats? We will see. So and these are the grades, different grades that we need to provide in the flexible payment. You should know the grades and with the hierarchy. Okay, at bottom which grade is there, above that which we should know that range also. Okay, at the bottom there is the natural subgrade, then there is the subgrade, then is the subbase, then base course, then binder, then surface course. Okay, and whenever we are providing the road on the soil, that is the natural subgrade, the first and the prior condition, we need to go for the checking of the stability of that soil. Okay, that we check the stability, the strength of that soil, load bearing capacity of the soil, then the E, that is elasticity property of that soil, subgrade reaction of that soil. Okay, that the properties, whatever that are required for our road purpose, that we need to check the that material called soil. Okay, we need to check the properties of the soil. We need to check the strength. We need to check the stability. We need to check the elasticity property of that soil. For that purpose, and ultimately, what we will find out the bearing capacity of the soil. Okay, this is very important to find out the bearing capacity of the soil. Depending on that, we will go with the different sizes and different types of layers in the flexible pyramid. Okay, so how much should be the layers and how much should be the sizes of the layers that are provided in the flexible pyramids? That is depend on the how much stress that should be transmitted on the side. Okay, and that depends on the bearing capacity of the layers. At no condition at all, the stress should not get increases beyond the bearing capacity. Okay. If it happens, what will happen? The road will get damaged there. Okay, it will get in the foundation. You might have seen if there is a low bearing capacity of the soil, the foundation will get settled down there. Likewise, if the foundation soil is not good, the road pavement also will get settled there. Okay, and if the road pavement gets settled, what will happen? Ultimately, there will be the cracks on that roads. Okay. Also, they have shown the layers here. The same diagram is there. And see here at the bottom, they have shown in the second diagram the stress distribution through the granular layers. As we have told that the distribution of the stress in the flexible pyramid, it is in the granular ways. Okay, because there are number of grains of the different kinds of stones, boulders, aggregates are there. Okay, so grain to grain distribution of the load will be there. Okay, so we will see now that there are different kind of the road layers. Okay. The typical layers of the flexible pyramid. The typical layers of the flexible pyramids are at bottom natural grade, subgrade, then the subgrade, sub-base course, binder, and the surface course. And in the surface course, we will provide the seal code, tag code, and we will get prime code. Okay, that you may provide, you may not provide. So, what is seal coat? The seal coat is a thin surface treatment used to waterproof the surface and provide the skid resistance. Okay, why the seal? What is the purpose of providing the seal coat? The objective of the seal coat is to give the waterproof condition for the road surface and also should provide the skid resistance on the top surface because seal coat is provided at the top. Okay, that you should know. At the top, there is the seal coat, then there is a tack coat, then there is a prime coat. Okay. At top, there is the surface layer, then the binder, then the sub-base, likewise. Base layer, sub-base layer, subgrade layer, natural grade. Then tack coat is a very light application of the asphalt, usually asphalt emulsion dilution with the water. Okay, tack to provide the tack coat, generally the asphalt layer is used and it is provided proper bonding between the two layers of the binder. Okay, why it is provided to give the proper bonding between the layers. Okay, binder layer and the surface layer will be there. To provide the proper binding between these two layers, we will provide the tack coat. Binding between the two layers of the binder course and must be thin, uniformly covered with the entire surface and set very fastly. Okay, it should be very thin and it should get fastly set. So seal coat is at the top to avoid the water to enter into the base. Okay, that is act as the waterproof layer and also it gives the proper provide the skid resistance. Tack coat, it is provided with the asphalt and it is provided for give the proper bonding between the two layers. Then prime coat is there. Prime coat is an application of the low viscous cutback bitumen. Okay, see here which material is used. The low viscous cutback bitumen is used. An absorbent surface like a granular base on which the binder layer is placed. Okay, binder layer is placed above the primer. Then above the binder layer, there is the tack coat, and then above the surface coat, there will be the seal coat. Okay, you should know the hierarchy as well. Okay, order of the coats, order of the layers. It provides the bonding between the two layers. Also, here also the prime coat it is also used for the providing the binding property between the two layers. Unlike tack coat, prime coat penetrates into the two layer below, plug the voids and the form the watertight surface. It is also helps to provide the watertight surface layer. Okay. The surface course. Then now this we have seen now the course. Now we will see the courses, that is the layers. At the top there is the surface course. The surface course is the layer directly in the contact with the traffic loads and generally contain the superior quality material. They are usually constructed with the dense graded asphalt concrete. Okay. What is surface layer? It is the topmost layer. Okay, which is directly in contact with the loads or with the wheel load. Okay, it is directly contact with the wheels, and generally it contains the superior quality because it is directly with the contact with the load. The higher or the maximum stress will be there on the surface force. Okay, because it is directly contact with the wheel, so there will be the higher stress on that layer. So we need to achieve the quality or the superior quality for that particular layer. So the surface course should be with the superior quality because it is directly connected with the tire loads. Also, it provides the characteristics such as the friction, smoothness, drainage, etc. Okay. Also, it provides the characteristic like it should be smooth. Okay. It should use the smooth because it should give the comfort condition to the driver. It should be gives a very good frictional resistance for skid of the vehicle. Then it should use proper drainage. Okay. The water should not get contaminated on the road. Also, it will prevent the entrance of the excessive quantities of the surface water into the drying base. Okay, base under underlying base, subgrade. It must be tough to resist the distortion under the traffic and provide the smooth and skid resistance riding surface. It must be waterproof to protect the entire base and subgrade from the weakening effect of the water. Okay, so these characteristics should be achieved by the surface. It should not give water enter into the base course. Okay, it should use the proper skid resistance so that it should use the riding comfort to the way driver whoever is driving on the road, and it should must give the waterproof protect to the entire layers below that. Okay. So these should be the characteristics of the surface layer. Then there is the binder course. This layer provides the bulk of the asphalt concrete structure. Its chief purpose is to distribute the load to the base course. The binder course generally consists of the aggregates having the less asphalt and doesn't require the quality as high as the surface course. So replacing the part of surface course by the binder course results in the more economical design. Okay. So what is the purpose of the providing the binder course? Distribute the load from the surface course to the base course. Okay, this is the purpose of providing the binder course. You may provide that course, you may not provide it there. if depends on the what traffic load conditions. Okay, and whatever the quality that we need to achieve for the surface course, we need not to go for that much quality of the binder course. As the stress produced or stress induced on that load, it is less as compared to the surface course. Okay, so we need not need to achieve that much quality that is actually in the surface course. Then there is the base course. Base course is the layer of the material immediately beneath the surface of the binder course. Okay, and it provides the additional load distribution and that contributes the surface drainage. It may be composed of the crushed stone, crushed slab, and the other untreated or the stabilized material. Okay, that layer base. What is the purpose of base layer? To transfer the load from the surface binders course to the subbase course. Okay, simply characteristics are there. Subbase layer, the purpose of subbase course to transfer the load from the base course to the subgrade soil. Okay, likewise, the load transfer mechanism will be there into the flexible units. And in the base course, we are using the crushed stones, crushed slags, and the other untreated stabilizer materials that are used into the base course. Then the sub base course will be there. Okay, sub base course is a layer material beneath the base course and primarily function are to provide the structural support to improve the drainage and to reduce the in intrusion of the fines from the subgrade to the pavement structure. Okay. See what is the purpose of the subbase course? To provide the proper base for the base course and also to transfer the load whatever coming from the base course to the downwards. That is subgrade. Also, it provides the proper waterproof layers. Okay. It should use the fine particles into that layer, so it gives a water technique property. Okay, so we can provide the subbase if there is the higher load. We use the more area to release the stress. If there is a less load, we can directly transfer the load from base course to the subgrades. It depends on the loads. These all layers, whether we should provide, how much should be the depth of that layer is provided, that totally depends on the load which is coming on the that pavement. Okay. Then the next is the last, at the last, what is there? Is subgrade. The top soil layer or the subgrade is the layer of the natural soil prepared to receive the stresses from the layers above. Whatever the layers, whatever the layers are above the subgrade layer, the stresses produced by the layer that are transferred to the subgrade layer. Okay, so subgrade layer is prepared to bear the stresses whatever they are transmitted from the layers above that. It is essential that at no limit soil subgrade is overstressed. It is very important. There should not be any overstress condition on that soil. If it will happen, what will be there? There will be the failure of that pavement. Okay, it will get settled down. It should be compacted to the desirable density. Okay, what we have to do, we need to achieve the desirable density near to the optimum moisture content that that you might have learned into the geotech. We need to achieve the optimum moisture content, because at the optimum moisture content, it will give us the desired density. Maximum density of the soil will be achieved at that point. Okay, so we need to achieve the maximum density of that soil by the, how we achieve, by the compactors. Okay, we will compact the soils with the help of compactor to achieve the maximum density of that soil. Okay, Then the rigid pavement have the sufficient flexural strength to transmit the will load stresses to the wider area. Okay. Up to now, we have discussed about the flexible pavement. Now we will see about the rigid pavement. Okay. The rigid pavements have the sufficient flexural strength to transmit the will load stresses to the wider area below. Okay. Compared to the flexible pavement, rigid pavements are the placed either directly on the prepared subgrade or on a single layer of a granular or the stabilized material. Since there is only one layer material between the concrete and the subgrade, this layer can be called as base layer or the sub-base layer. See here, in the rigid pavement, we can directly transfer the load from the surface core to the subgrade soil. Whatever the layers are there in between this, we can remove directly into the rigid pavement. Okay. And also we can provide only one layer between these two, between the surface layer and the subgrade soil. We will provide at least one layer. That layer may be called as base layer or sub-base layer. So since there is only one layer that we have provided between this, we will call it as base layer or sub-base layer. And as compared to the flexible pavement, the rigid pavement is directly we can place either directly on the subgrade or either we can provide one layer between the subgrade and base course, surface course. Okay. See here, you can see you might have observed somewhere whether there is condition or the construction of the rigid pavement or the concrete road is there. You might have observed like this pavement. Likewise, the steel rods are placed, okay, to achieve the proper bonding between the two adjacent lanes or the layers of the concrete. To achieve the proper bonding between two adjacent layers, provide the steel bars. Also, when there is the temperature stresses and the concrete tries to elongate, that binder or the steel rods tries to keep it into the proper position. Okay, so this rod act as the binder between these two pavement layers. So this is the typical layers of the concrete road. This is the typical layers for the concrete road. We'll draw this diagram for the rigid, give the heading as rigid pavement. Rigid pavement. Draw this figure. Done. Okay. Okay, we will see now the pavement materials. What are the materials? What should be the qualities of that materials? What should be the tests that should be performed on the different materials? And we will begin with the soil. The first and most important material is the soil. The pavements are the conglomeration of the materials. Means what? Conglomeration means what? Combinations of the different kinds of the materials. Okay, pavement is the structure which is made up of the different constituents or the different contribution of the different kind of materials. These materials, they are associated with the properties and their interaction determine the properties of the resultant pavement. Okay. So what materials that we have used for the road construction, what are their associated properties and the uh, all these characteristics, if we go in detail, then we will understand the what will be the properties of the pavement. Okay, because the properties or whatever the resultant qualities of the pavement will be there, that are totally depends on the materials that we have used for the construction. Okay, so to achieve the quality or to achieve that property of that pavement, we need to go for the proper materials, okay, whatever we require. Thus, a good understanding of this material, how they are categorized, how they are performed to fundamental understanding pavement, the material which are used construction of the highway and the intense interest to the highway engineer. So to understand these characteristics of the pavement, we have to understand the materials. Okay, how they are characterized, how they perform the fundamentals, how they perform their activity, active performance into the pavement. Okay, how does affects if there be variation, do the variation in the material. Okay, that we need to understand. Soil is the accumulation or the deposit of, of earth material derived naturally from the disintegration of the rocks or the decay of the vegetation that can be excavated readily with the power equipments in the field or disintegrated by the gentle mechanical means in the laboratory. Okay. So what is the soil? Soil is simply structure which is deposited in the earth of the earth material. It is derived naturally from the disintegration of the rocks. Okay, how the soil is formed? It is by the disintegration of the rocks or by the decaying of the vegetables, animals, etc. Okay, so that soil we need to extract by the equipments and we need to go for study on that. Okay. The supporting soil beneath the pavement and its special under courses is called as subgrade. Okay, so these whatever the soil beneath that pavement will be there, that soil is called as subgrade. Undisturbed soil beneath the pavement is called as natural subgrade. Okay, the soil is divided into two ways here: subgrade and natural subgrade. What is the subgrade? In this subgrade, we will do the compaction or whatever we want to do on the test, etc. on that soil. The compaction on that soil, that is called as subgrade. Means what, we are doing something on that soil. Okay, but if the soil it is there naturally, which is undisturbed, you might have learned into the geotech. There are two kinds of soil: disturbed and undisturbed. You have to perform the test in the both the states, disturbed soil and for the undisturbed soil. Okay, if there is the undisturbed soil, means what, we have nothing done on that soil. Okay, as whatever the soil it is there naturally in the earth crust, that will be there. Okay, so that naturally layered soil will be there. That is called as natural grade. Okay, so it is called as natural subgrade. And whatever we have performed, if we have performed the compaction etc. on the soil, that will be considered as a subgrade soil. Okay, understood? The soil is derived into two types: natural subgrade and subgrade. In the natural subgrade, we have done nothing. Okay, whatever the qualities, whatever the characteristics, whatever the layer of the soil will be there naturally, it is as it is. We have not done nothing, anything. That is means what? It is undisturbed. Okay, it is called undisturbed soil. If there is undisturbed soil, it is called as natural subgrade. And if you have done the compaction, etc., on that soil to achieve the maximum density, what we do? Compaction on the soil. Okay, if we have done the compaction on that layer, it is called as subgrade soil. Okay, compacted subgrade is the soil compacted by the controlled movement of the heavy compactors. Okay, for the compaction, what we use? Different kinds of compaction compactors or the heavy machineries are there, and it depends on the types of the soil. Okay, which kind of machinery or the compactor we have to use, it depends on the soil. If there is a clay soil, we require different kind of the compactor. If there is a sandy soil, we require different kind of compactor. Okay, so depend on the soil, the compactor will differ. You can see here the subgrade soil layer, it is shown here. It is compacted, you can observe. This seems to be compacted by the machineries. Then they will apply the paper on that, and they will place the concrete layer. We will see now the soil types. The wide range of the soil types available as a highway construction material have made it obligatory on the part of the highway engineers to identify and classify the different soil. Okay. So there is need to find out the which type of soil is there. Okay. Because depending on the type of soil, the characteristics of the soil will get different. So we need to understand first the type of soil that is there. And the broadly the soil types are can be categorized as laterite soil, murum or the red soil, desert sand, alluvial soil, clay, including black cotton soil. So we need to understand the first we need to find out the what type of soil is there, and then we need to understand what should be the what we should have to done for that soil to achieve the optimum density. Then the soil types also shown here in the pyramids, like clay, sandy soil, clay loam, silty clay, sandy clay loam, silt clay loam, sandy. Means what? How much percentage of clay it is there? How much percentage of silt is there? How much percentage of sand is there into the particular soil? Depending on that percentage, the different types of the soils are shown here. You can take the screenshot of this. Depending on the percentage of sand in the soil, depending on the percentage of clay into that soil, depending on the percentage of silt into that soil, the different kind of the soils are shown here. Okay. Very nicely shown by the grids here by using the pyramid. Just take a screenshot. Else, if you want, you can draw. I'm being take the screenshot. Afterwards, you can draw in your node. Okay. So see how the soils are characterized or classified. Soil classification done as like gravel, sand, silt, and clay. Okay. If it is greater than 2 mm, it is called gravel. In between 2 mm to 0.06 mm, it is called sandy soil. If it 0.6 mm to 0.002 mm, then it is called as silty clay soil. And if it is less than 0.002, that is 2 micron, then it is called as clayey soil. Okay, please write down this table. This is a very important table. All of you, please write down this table. This is called soil type. Okay, this is for soil, not for aggregates. Please remember, this table is not for the aggregates. There are different ranges for the aggregates. This is for the soil types. Please write down this table. When we call the soil as a gravel soil, when we call it as sandy soil, silty soil, clayey soil. Okay, so depends on the sizes. Please draw this table. Done.
No, sir.
Okay. If you have done, we will move forward. See here also they have given some information about the gravelly soil, murum, silt, clay. What is gravel? These are the coarse materials with a particular size under the 2.36 mm with the title little or no fines contributing to the cohesion of the materials. Okay. So when we call the gravelly soil, as we have also seen into the pictures, if that soil is above the 2 mm, the 2.36 mm, it is called as gravelly soil, and it has the little or fine contribution of the cohesive materials. Okay, there is not that much cohesion between the gravelly soils. Okay, and they are in the larger size. Maximum cohesion will be there into the black bottom side. Okay. Moreover, these are the product of the decomposition of the weathering of the pavement rocks. Okay. How the murum is formed by the weathering. Visually, these are similar to the gravel except the presence of higher content of the fines. Okay. Murum soils are seems like a gravelly soil, but except thing is that it contains the higher content of the fines area. Okay, fines will be the higher. Then there is silt. These are the finer than the sand, brighter in the color as compared to the clay, and exhibit the little coherence. Okay. What is silt? These silts are finer than the sand and it has the brighter color. Okay, as compared to the clay, and it also exhibits the cohesion property. When the lumps of the silty soil mixed with the water alternates fused and the trapped in the shiny surface makes its appearance. Thus, dilatancy is the specific property of such a soil. Okay, so because of the such a property of when the soil is get fused with the water, when the soil is mixed with the water, it skews and drip into the surfaces. Okay, so it's this soil will give the properties like the dilatancy. Okay, the dilatancy is the specific property of the silty soil. The clay, these are the finer than the silts. The soil which is finer than the silt is called as clay. Clay soils exhibit the stickiness, high strength when the dry, shows the no dilatancy. Black cotton soil and other expensive clays exhibit the swelling and the shrinkage property. Paste of the clay water when rubbed into the finger leaves strain, which is not observed into the silt. Okay. The special characteristics of the clay is the what? It is the black cotton soil and it exhibits the swelling and the shrinkage property. Okay. What is the property of the clay? It is gives the exhibit property like the swelling and the shrinkage property. And it is due to the presence of the different materials into the black cotton soil. Okay. The paste of the clay with the water when rubbed into the fingers leaves the stain, which is not observed into the silty soil. Okay. When we take the gravel, clay soil, it will get stick into our fingers. It will get use the stain, but it is not observed like into the silty soil. Okay. Then the tests on the soil. What are the tests that we are performing on the soil? The subgrade soil is an integral part of the road pavement structure as it provided the support the pavement from the beneath. The subgrade soil and its properties are important in the design of the pavement structure. The main function of the subgrade is to give the adequate support to the pavement, and this the subgrade should possess the sufficient stability under the adverse climate and the loading condition. Therefore, it is very essential to evaluate the subgrade by the conducting the different kinds of tests. Okay, as the subgrade perform very important property to transfer the load from the pavement. Okay, because whatever the load that is coming from the pavement that is transferred to the subgrades. Okay, so understand the property of that subgrade. We need to perform certain tests on the subgrade. So the test used to evaluate the strength properties of the soil may be broadly classified into the three types: shear test, bearing test on the soil, and the penetration test. Okay, so to understand the strength of the soil, we're going to perform the different kind of the tests. First one is the shear test, another one is the bearing test, and the last one is the penetration test. Okay, so these are the tests that we are performing on the soil to find out the strength property of the soil. Okay, now is strength CBR test. It is a very long test. We'll see in detail. So you'll see that test, CBR test, how it is performed into the next lecture. We'll stop here only. We'll stop here only. You'll see the remaining part of the lecture in the next lecture. If you want, you can draw this diagram, take the screenshot and draw afterwards. Please mark your attendance to the chat box, then you can leave the lecture. Mark your attendance to the chat box. Mark your attendance to the chat box, then you can left.